let us discuss about signed 1's complement representation. So this is one kind of representation by which we represent negative numbers. So before we go to the signed complement representation, let us understand what is the 1's complement operation. The 1's complement representation and 1's complement operation both are different. Now in 1's complement operation, each and every bit of a number of any binary representation, if we apply 1's complement, then each and every bit will be complemented. Now let us take an example and understand this. Suppose we have a binary code like this. Maybe it is a number or anything which has been converted in binary. Now if we apply this on the 1's complement on this, then each and every bit of this representation will be complemented like this. So after 1's complement, after one complement operation, this becomes like this. This 1 is converted to 0. This 0 after complement become 1, and 1 becomes 0, and so on. So this is how the 1's complement operation works. That is, whatever the binary representation we are given as input, after 1's complement operation, each and every bit of that representation will be complemented. Now let us concentrate on signed 1 complement representation. So this is the one representation mechanism by which signed number can be represented. So by using signed 1's complement representation, both positive number and negative number can be represented. Suppose we have a positive number like this, say positive 12, that is plus 12. After 1's complement, so after 1's complement operation, it becomes negative 12, that is minus 12, and the vice versa is also true. If we apply, we can make the arrow bidirectional. That is, if we apply 1's complement operation on any signed number presentation, then the sign of that number changes. If before 1's complement operation the signed number is positive, then after 1's complement operation it becomes negative, and if it is and the vice versa is also true. That is, if it is firstly it is negative, then after 1 complement operation it becomes positive. Now let us take a binary example. So this is the binary representation of plus 12. Now we will apply 1's complement operation on this. So after 1 complement operation, what happens? Each bit of this representation will be complemented, including the sign bit. So we get this one. So actually before 1's complement operation, this signed number was plus 12, and after 1's complement operation this becomes minus 12. Now if we apply 1's complement operation on this once more, then we will get back the positive number, that is plus 12. So now let us summarize what we have discussed till now. That is, main 2 points we have discussed till now. One is we need to distinguish between the 1's complement representation and 1's complement operation. That is, 1's complement operation can be applied on any binary presentation available, and after the presentation, what happens? Each and every bit is complemented. Now if we apply the 1's complement operation on the presentation of any signed number, then the sign of that number after 1's complement operation changes, and by using 1's complement representation, both positive number and negative number can be presented. Positive number, presentation of positive number in all of these signed number representation methods like signed magnitude method, 1's complement method, and 2's complement method. In all of these 3 cases, the presentation of the positive numbers is same, and the presentation of the negative numbers is differs in all of these cases. Now in our next video we will discuss about the range of 1's complement representation. That is, what is the range of number by which we can represent by using 4 bit or 5 bits, etc.